Okay, I guess it's recording. I don't know, it's hard to tell. So it's been a while since I made one of these videos, but we've got something that I haven't usually done, so here we go. This is going to be called Lesson 1.7, which is partitioning a segment. All right, so a directed line segment is a line segment with an associated direction. Of course, I do not have the space for that. So if this is a directed line segment AB, we would say that point A is the initial point, initial meaning beginning, and point B, the coordinates of point A, we would call them x1 and y1, and point B would be the terminal point, terminal meaning ending. And we would give that the coordinates x2, y2. And the reason this matters is because when we're partitioning a segment, we care about the direction of the segment, if that makes sense. So a directed segment has a horizontal component, which we call the run. And the way that we find that is just by subtracting our x values, x2 minus x1. Minus x1. And it also has a vertical component called the rise, which we get by doing y2 minus y1. So our vertical component, y2 minus y1, our horizontal component, x2 minus x1. So first question it's asking us to do is find the horizontal and vertical components of directed line segment PQ to the left. So P is our initial point, and the coordinates of it are 1, 2. Q is our terminal point, and its coordinates are 1, 2, 3, 4, 5, 6, 10, 1, 2, 3, 4, 5, 6. So our horizontal component is going to be our second x value, 10, minus our first x value, 1, or 9. And our vertical component is going to be our second y value, 6, minus our first y value, 2, which is 4. All right, and then number 2, find the horizontal and vertical components of directed line segment CD with coordinates at C, -2, 6, and D at 1, -1. So C is our initial segment, x1, y1, and D is our terminal point, x2, y2. So my horizontal component is going to be x2 minus x1, 1 minus -2, and that equals 3, because when we have two minuses, we can change that to a plus. My vertical component, y2 minus y1, is -1 minus 6, which is -7. All right. So moving on into partitioning a segment. To partition means to separate or divide. We can partition a line segment into smaller segments and compare their lengths as a ratio. So if segment AB is partitioned into into 5 congruent parts, it's asking us to give each ratio. So AP from A to P, we have 1, 2, 3, and from P to B is another 2. So we have 3 here to 2 here. And then for AP to AB, so AP is still 3 parts, but the whole AB is 5 parts. Right? So we've got 2 parts and we've got a whole. Okay. On our next page, assume the segments are partitioned into congruent parts. Identify each ratio. So this whole thing is divided into 3 equal parts. 1 part AP, 2 parts PB, and the whole is 3. So AP to PB would be 1 to 2. AP to AB would be 1 to 3. And then on number 5, so AP is 1, 2, 3, 4, 5 parts. PB is 1, 2, 3. And that means the whole is 8. AP to PB is 5 to 3. AP to AB is 5 to 8. So all it is how long is this piece, how long is that piece, and then you put a colon between. All right, so finding coordinates. What if we want to find the coordinates of a point that partitions a directed line segment into a given ratio? So we've got 3 steps that we can follow for that. The first is you want to write your ratio as part to whole in fraction form. So sometimes you'll be given like part to part ratios, but you always want to convert to part to whole. And the way that you do that is you just take whatever part you have as your given part. So like for AP to PB, it was 1 to 2. AP to AB, AP is still 1, but AB is going to be 1 plus 2, or 3. Right? 5 to 3, AP is still 5, but AB is 5 plus 3, 8. Multiply the horizontal component by the ratio from step 1, and then add this value to the x-coordinates of the initial point, and that is your new x-coordinate. And then you do the same thing with the vertical component, the rise. So given directed line segment AB below, it wants us to find the coordinates of P such that AP to PB is 1 to 3. So AP, P is going to be somewhere on here. PB is the rest of it. So this is a part-to-part ratio. We need to convert it to a part-to-whole ratio, AP to AB. So AP is still 1, but AB is going to be 1 plus 3, or 4. And we can rewrite that as a fraction, 1/4. Then our initial point here is A at -5, -1, and our terminal point is B at 7, 7. So we're going to find the horizontal component. So that's x2 minus x1, and x2 is 7 minus x1 is -5. That would be 12, and then we're going to multiply it by that 1/4. 1/4 of 12 is 3. So that's our x-coordinate for our new point. Or not. Oh, no, wait. That's not right, because then we have to add the value to the x-coordinate of the initial point. So then we have -5 plus 3, and that's -2. So this is the actual answer that we need. not this. My bad. All right, and then vertical, y2 minus y1 is 7 minus -1, which is 8. 1/4 of 8 is 2. And -1 plus 2 equals 1. So point P is -2, 1. And our final answers on these ones are going to be coordinate points, like our final answers on midpoint questions were coordinate pairs. Okay. So we're going to do the same thing over on number 7, given the directed line segment RT. So this time our initial point is the one that's on the right side, and our terminal point is on the left, right? And you can tell because they put the initial point first in the name of the segment. And we need to find the coordinates of S, so that RS to ST is 5 to 1. So RS, ST is 5 to 1. That means that RS to RT is 5 for RS, and then for RT it's 5 plus 1, or 6. So that is 5/6. Okay, so point R is at 7, 1. Point T is at -5, -5. So we find our horizontal component, x2, -5 minus x1, 7, is -12. Times that by 5/6. And you get, I think, -10. So then our R1 is 7 plus -10. Our new x value is -3 for coordinate S. And our vertical component, y2, -5, minus y1, 1, makes -6, times 5/6 equals -1. And then 1 plus, sorry, hold on, my brain. Right, adding it to our initial point. 1 plus 1 equals 2. All right. Sorry, the answer key I have is actually wrong, but I didn't make it. So it's -3, +2. I'll fix that, sorry. +2. And that is the coordinate for point S. And if you want, you can kind of partially check this by graphing the points you get at the end. So P -2, 1 would be here. So at least it's on the line. That's a good sign. And for S, sorry, this is (1 plus -1). That still doesn't make sense. And I'm so confused because we're adding initial with the thing. 7 plus negative 10 is negative 3. One plus negative 1 should equal 0. But that isn't where it is. I don't know. This one is weird because the answer key shows it at negative 3, negative 4. So unless oh, I know what it is. 5, 6 times negative 6 is negative 5. That's why it's not working. Okay. 1 plus negative 5 is negative 4, which is what we needed. Sorry about that. My brain is having a day. So this one is at negative 3, negative 4, and that is on our line. So we can guess that we've possibly done this right. Or, you know, if you're me, done it wrong and then had to fix it. But that's okay, because making mistakes is how you learn. So you want to be careful with that multiplication, right? You have a calculator, so you might as well use it. All right. We have another one like that. Let's hope this one goes a little bit better than the last one. Given directed line segment JL, so here's our initial point, here's our terminal point. Find the coordinates of k, so that's the ratio of jk to JL. So this is already given as part to whole. Seven to 8, which we can rewrite as 7 over 8, right? JK is our part, JL is our whole. And we know that because we have JL here. All right, so point J is at negative 6, 5. Point L is at 2, negative 5. So our horizontal component, y2 is 2 minus y1, negative 6. That is 8 times our 7/8 is 7. And then we add that to our initial point, negative 6 plus 7 equals 1. Vertical component, we have negative 5 minus 5 equals negative 10 times 7/8 is negative 8.75. And then we're going to take our initial point 5 plus negative 8.75. Negative 3.75 is our ending point for that. And point K then is at 1, negative 3.75. So 1, and then 1, 2, 3. That does look like it's at about negative 3.75, so I think we are good on that one. All right. So now that we've done sort of the more complicated way, we can actually learn a formula for partitioning a segment. So kind of like we had a formula for midpoint, this is a formula for partitioning a segment, and it's going to look kind of like the midpoint formula, so I'll write it in 2 ways. So given a directed line segment AB with coordinates A at x1, y1 and B at x2, y2, if point P partitions AB such that the ratio of AP to AB is k, and that's going to be our fraction that we've been getting, then the coordinates of P are k times x2 minus x1 plus x1 and k times y2 minus y1 plus y1. So then we'll say our x for the partition segment is the k times x2 minus x1 plus x1, and our y for the partitioned segment is k times y2 minus y1 plus y1. Right, so again, you can do it, you can think of it as a whole formula with the commas, or you can think of it as two separate formulas, and then you end up with the answer xp, yp. And it's very important, the ratio has to be written part to whole in fraction form. Otherwise, it will not work. So, more examples. Given a, b, with a at 3, negative 1, so I'll label those my x1, y1, and b at 8, 14, x2, y2. P lies on AB such that the ratio of AP, that's a part, to PB, that's the other part, is 2 to 3. So we need to convert that to a part to whole. So AP is 2, AB is 2 plus 3, or 5. So we write that as 2/5. And then we can just plug it into our formulas. 2/5 times x2, 8, minus x1, 3, plus x1, 3. 2/5, 8 minus 3 is 5. 2/5 times 5, sorry about that, is 2, plus 3 is 5. And then for the y component, y2 is 14, minus y1, negative 1, plus negative 1. And 14 minus negative 1 is 15, because those minuses turn to plus. 2/5 of 15 is 6. And that's also 5. So our answer for this is 5, 5. All right. Number 10, similar, another example given MP. M is negative 12, negative 5. I'm just going to write it over here so I've got space. P is 9, negative 12. And N lies on the segment such that the ratio of Mn to Np, those are both parts again. So then Mn to Mp will be 3, and then 3 plus 4 is 7. And we need to find the coordinates of n, that point in between. So we take our 3/7, x2 is 9, minus x1, negative 12, plus x1, which is still negative 12. 9 minus negative 12 is the same as 9 plus 12. 3/7 times 21 plus negative 12. 3/7 times 21. So I can do this by taking 21 divided by 7, that's 3, and then times it by 3. 9 plus negative 12 equals negative 3. And then finding our y component, negative 12 minus negative 5 plus negative 5. And negative 12 minus negative 5 is negative 7. 3/7 of negative 7 is negative 3, plus negative 5 is negative 8. So our answer, negative 3, negative 8. We're going to do number 11 as well, but I will leave 12 through 14 for you to do yourself to make sure that you can do this. 11, given xz with x at 1, 9, and z at 5, negative 11. And y lies on xc such that the ratio of xy to xc, so that's already part to whole, is 1/4. Find the coordinates of y. So I can do 1/4 times x2, 5, minus x1, 1, plus x1, 1. 1/4 of 4 plus 1. 1/4 of 4 is 1, plus 1 is 2. 1/4 of y2, negative 11, minus y1, 9, plus y1, 9. Negative 11 minus 9 is negative 20. 1/4 of negative 20 is negative 5, plus 9 is 4. So this one is at 2, 4. Okay, so we've done some practice doing partitioning with the formula. Like I said, I'll leave 12, 13, and 14 for you to do yourself. And then we'll move on to the applications, which are 15 and 16. In a certain town, the mall is located 1 mile west and 8 miles north of the post office. The library is 5 miles east and 2 miles north of the post office. If Alana's house lies 2/3 of the way between the mall and the library, find the location of her home relative to the post office. So for this one, we're going to call the post office our origin, and then our mall, 1 mile west, would be at -1, 8 miles north, +8, so that's the mall. And the library, 5 miles east and 2 miles north. Okay, so mall, -1, 8. Library, +5, 2. And that's just assuming west is -1 mile, north is +8, right? North, east, south, and west, if we're breaking it up like that. And Alana's house is somewhere on this line segment. Okay, 2/3 between the mall and the library. So I believe that means our fraction is just 2/3 as it was given, right? Because it's 2 to 3 for their part to whole. So then we will plug into our formula. 2/3 times x2, 5 minus x1, -1, plus x1, -1. 2/3 of 6 plus -1. 2/3 of 6 is 4, plus -1 is 3. And then for our vertical, 2/3, 2 minus 8 plus 8. 2/3, that is -6 plus 8. So now -4 plus 8 is 4. So it's going to be 3 miles east, 4 miles north, right? 3, 4. And you can sort of 1, 2, 3, 2, 3, 4, right there. Alana's house. Okay. Number 16. 2 cruise ships left the same port after 2 hours. Let me see. We're doing west and north-south. So I'm going to actually go like this. So this is our port. Ship A is 30 miles west and 18 miles north. And ship B is 10 miles west and 27 miles south. -10, -27. If there is a tugboat located 1/5 of the way from ship A to ship B, so that's our 1/5 is our ratio, we want to find the location of that tugboat relative to the port. So our ratio is 1/5, and we're going to plug that in. 1/5, x2 is -10, minus x1, -30, plus x1, -30. 1/5 of -10 minus -30 is 20, plus -30. 1/5 of 20 is 4. And 4 plus -30 is -26. And then for our other component, 1/5, y2 -27 minus y1 18 plus y1 18. -27 minus 18 is -45. And 1/5 times -45 is -9 plus 18, 9. So that is west and north, 26 miles west, 9 miles north, or we could write it as -26, 9. And that is our application problems for this one. A lot of navigational stuff. And that is all for this lesson. So I'm going to go ahead and close out. Make sure you pause the video if you need to get what you're missing.